Welcome back to another video. It's your favorite math professor here, Dr. Tarcia Hubert. And in this video, we are going to talk about the standard normal distribution. And here we're going to start off with the definition. So suppose that the random variable x is normally distributed with mean mu and standard deviation sigma. Then the random variable z is equal to x minus mu over sigma. Is normally distributed with mean mu equals 0 and standard deviation sigma equal 1. So basically, we can, if we know the mean and the standard deviation of a normally distributed variable, then we can convert that to a standard normal variable. All right, and that's our z here. So the random variable z is said to have the standard normal distribution. So basically, we're taking all of our normally distributed probability distributions or our normally distributed variables, and we're converting them to a standard variable, okay? And that is our z. This is what the standard normal curve look like. So it becomes standard because they have a mean of 0 and a standard deviation of 1. It allows us again to compare apples to apples. It basically standardizes our variable. And so we use a z table to find the probability. Once we have made it a standard variable, we use the z table to find the probability. The z table gives the area under the standard normal curve for values to the left of a specified z variable. So if this is our z variable in the chart, it's going to give us the probability of everything to the left of that variable. Alrighty, so let's look at an example. And here's what this is a portion of the z table. Is actually longer than this, bigger than this, but I have screenshot a portion of it just to show you what it looked like. And so we will use this z value over here, and this gives us the 100 decimal place. So this gives it to the 10th, and we find this value over here to make it to the 100 decimal place. So now let's look at an example. IQ scores can be modeled by a normal distribution with mean equal 100 and standard deviation equal to 15. And we want to know two things. First, what is the probability that an individual scores 100 or lower? And then what is the probability that an individual scores higher than 120? So what we want to do is we want to standardize this variable because it is normally distributed. We can standardize it by using that formula. Z is equal to x minus mean over sigma. Well, our x here, we're going to use 120 because that's the data we want to know. And then our mean is 100 and our standard deviation is 15. So 120 minus 100 is 20 over 15. And that becomes 4 over 3, which is approximately 1.33. It's 1.33 repeating, but if we round it to 2 decimal places, it's 1.33. All right. And so that is our z-score. That is our standard value, okay, for the standard normal distribution. And now we want to use the table to figure out the probability for everything less than that value, all right? So let's go to look at the table. And we're doing 1.33. So 1.3 is here. So to get to 1.33, I will have to go all the way down to the 0.03. So we go here because it's to the 10, 1.3, and then the 100 decimal place is a 3. So we will go here, and this is our probability right here, 0.9082. So the probability of it being less than 120 would be 0.9082. So I'm going to go back to this. So our probability here is 0.9082. And that's the probability of it being less than, all right? Now, if we want to find, that's 120 or lower, but if we want to find the opposite, bigger than 120, we will use that complement rule, right? Where you do 1 minus that probability. 1 minus 0.9082. And when you do 1 minus 0.9082, you get 0.0918. So that will be the probability that an individual scores higher than 120. And we just found that by taking 1 minus this 0.9082. And here's an image that demonstrates that problem. So the area to the left of 120 is 0.9082, which we got out the table. So that would be the probability of getting less than 120. And then the area to the right is the 1 minus that, which is the 0.0918. And that will be the probability of getting higher than a 120. All right, let's look at another example. A pediatrician obtains the heights of her 3-year-old female patients. The heights are approximately normally distributed, so that is key here, that it is normally distributed, with mean of 38.72 inches and standard deviation of 3.17 inches. Use the normal model to find the probability that a randomly selected 3-year-old girl is between 35 and 40 inches inclusive, meaning including the 35 and the 40. That is, find the probability that X is between 35 and 40 here. So in order to find the probability in between those, we need to both standardize the 35, find the z-value for that, and the z-value for the 40. So we're going to have to do two different problems here. X is equal to, not X, Z. We have to find the z-value. Z is equal to X, which is 35, minus the mean, which is 38.72, divided by the standard deviation, which is 3.17. So that's for our first, that's a Z right there. That's for our first one. And when you work that out, you end up getting negative 1.174. All right, so that's the Z value for 35. Now we have to find the Z value for 40. So we would do Z is equal to X, which is 40, minus the mean, which is 38.72, all over the standard deviation, which is 3.17. And if you work that out, you end up getting a Z value of 0.403. All right. So we have two different Z values. The first one is negative 1.174 and the second one is 0.403. So we have to look at the Z table and find the probability that corresponds to both of those Z values. So let's look at the tables. So for the first one, and I have it, because the Z table is so big, I have it broken up into two different ones. So here is my positive Z values. So I'm going to find my positive Z first, which is the 0.40. So I'm going to go to 0.4 here. And then since it's 0.40, then I'll just go right here. 0.40 will be this value, 0.6554. So let's keep that in mind, 0.6554. Write that down so you remember it. And then I'm going to go to a different part of my table to get to the negative value. My negative Z score was negative 1.17. So I'm going to go to negative 1.1. And then I'm going to go all the way down here to the 0.07. So negative 1.17 will be this value here, the 0.1210. Okay. So keep those values in mind. And I'm going to go back here and I'm just going to kind of make a sketch of what that would look like. So I have a normal curve. I have a Z value over here that's negative 1.17. I have a Z value over here that's 0.4 somewhere. And so that value of the value that we got of 0.6554 is the area that is underneath this curve. All right. So that is the 0.6554. And then I'm going to change my color here and make it orange. And that other value we got, a 0.1210, is this part right here, the part that's in orange. That's the 0.1210. Now I'm going to change my color again. The area that I'm looking for is this area in the blue. So everything in between those. So in order to find the area in the blue, what I need to do is take the black part, the 0.664, the 6554, and subtract the orange part from it, the 0.1210. So that means I'm taking this big area here and subtracting this orange area from it, and that's going to give me the blue area. And when I subtract that out, I get a total of 0.5344. And so that would be the probability that a randomly selected 3-year-old girl is between 35 and 40 inches tall, the 0.5344. All right, if you have any questions, don't hesitate to put them in the comments. Hopefully it's making sense. This next slide is going to show just a general description of how you find the probability for each. So if you just want the probability of a value that's less than that value x, the probability of a value less than x, you use the z-chart to find that probability. That value that's given in the z-chart is that probability. If you want it for bigger than, then you have to do 1 minus, and here it is right here, 1 minus the area to the left of z. So whatever value you get in the z-chart, you have to do 1 minus that. And then if you want it for in between two values like we just did, then you have to do the area of the biggest value first. That's your x2, your z2 here, minus the area to the left, the smallest value, your z1. All right, so you would do the value you get from the chart of this big area minus the value you get from the chart of this small area. And that's what we just did on that last one. All right, sometimes you may need to find the data value given the probability. And in this case, you will use the z-chart to find the z-value and then calculate x using the following formula. So if you manipulate your formula you had before, z equal x minus the mean over the standard deviation, then you end up getting x is equal to the mean plus z times the standard deviation. So that is the formula you will use for that. All right, so for this example, the heights of pediatricians' 3-year-old female patients are approximately normally distributed with mean 38.72 inches and standard deviation 3.17. So same information as the last problem. This time we want to find the height of a 3-year-old female at the 20th percentile. And what that means is we want to know what is the value of x now that would give us a 20% probability under the curve. So for this problem, we would have to look at the z-chart and find where the probability is 0.20. So I'm looking, and I want to get the value closest to 0.20 as possible, which will be this value right here. And if I go to the left, it will give me negative 0.8. And if I go up, it would give me 0.04. So negative 0.8 and 0.04, that gives me negative 0.84. So negative 0.84 is my z value. So I'm going to calculate x now given that z value. So x is equal to the mean, which is 38.72, plus z, and I don't have no space, but our z was negative 0.84, times the standard deviation, which was 3.17. And if you work that out, you end up getting x is equal to 36.05, and in this case it will be inches. So the height of a 3-year-old female at the 20th percentile will be 36.05 inches. All right, so that's how you would find the x value given the percentage. Alrighty. Some notation we need to know is this z of alpha, z sub alpha. This is the z-score such that the area under the standard normal curve to the right of z alpha is alpha, okay? So it looks like this. So z alpha is the probability where to the right of that value is alpha. So for example, find the value of z of 0.10. So what that would look like is if we had a standard normal curve, z 0.10 would mean that this value here is 0.10. So that means the area to the left is going to be 1 minus 0.1, which is equal to 0.9. So we want to look in the chart to find where the area is 0.9 or as close to 0.9 as we can get. So I'm in my z-chart, and here's 0.9015 and 0.8997. This one is closest to 0.9. So that is 1.2 and that is 1.28. So that is the value we would get for z. So our z of 0.10 will be 1.28. This is the z value that will give us a basically 10% probability that is bigger than that z value right there. And one last thing I want to hit on is that with a standard normal distribution, the probability of any single value is 0 because there is no area under the curve there. And so therefore, all of these probabilities are equivalent. So whether you have a line underneath or not, it's going to give you the same probability, all right? So let me know if you have any questions. Thank you for watching this video, and I will see you all in the next video.